this video, I'm going to go over how to complete Lab 6. Here I have my DC power supply, the tangent galvanometer, the high current sensor, Vernier LabQuest, and a laptop, a compass, and a ruler, and a magnetic field sensor. First thing you're going to do is connect the DC power supply to the high current sensor, to the tangent galvanometer, back to the DC power supply. Make sure when you connect the tangent galvanometer that you have the wires connected between the 15 turns. Between these two probes we have 10 turns, between these two we have 5, but we want them connected between these two so that we have 15 turns. When a current flows through the tangent galvanometer, it'll enter through this side, and then the current will travel around the tangent galvanometer in this direction. And so if the current is flowing in this direction, then the magnetic field due to this current wraps around the tangent galvanometer in this direction. So if magnetic field pointed in this direction and then all around the tangent galvanometer, and then a magnetic field pointed upward in this direction throughout the entire inside of the tangent galvanometer. And then the high current sensor and the magnetic field sensor are going to plug into the LabQuest, and then you're going to open the laptop, open Logger Pro, and connect the LabQuest to Logger Pro, or connect the LabQuest to the laptop. After connecting the LabQuest to the laptop, you're going to see 3 graphs appear. First thing you're going to do is delete 2 of these. I'll delete this graph and delete this graph, and then this graph I will expand it and then I'll change the x-axis to current. Now our graph is of magnetic field versus current. Make sure the power supply is off, and then you're going to zero both the magnetic field sensor and the high current sensor. On the top right here, you're going to click over here and hit 0, and then wait for it to 0, and then 0 the magnetic field sensor as well. Now we're going to turn on the DC power supply, and when I place the magnetic field sensor into the center of the tangent galvanometer, right here in the center, with the tip in the center, not the beginning of it, with the tip in the center, then we see a current reading of 1.32 amps and a magnetic field of about 2 milliteslas. If I place the magnetic field sensor into the tangent galvanometer the other direction, I'll get a negative reading. On this side I get a positive reading. It does not matter, it's just negative and positive. As I increase the voltage on this power supply, then the current and the magnetic field increase. If I decrease the voltage, then the current and magnetic field decrease. What we're going to do is hit collect on Logger Pro, and then increase and decrease the voltage so that we are going in between the minimum and maximum limited current on the DC power supply. And you'll do this until the Logger Pro automatically stops. And then we'll auto scale the graph. What this does is it plots a bunch of points between currents of 0 and your current limit, and then the magnetic field that corresponds to that point. And it'll display these points in a graph like this. Then what you're going to do is take a linear fit of this graph by clicking this button right here, linear fit, and then I see the slope is 0.1401 milliteslas. The second part of the lab requires the compass. In this part of the lab, we're going to get all equipment as far away as possible from the tangent galvanometer and the compass, so that the magnetic fields of the laptops, the DC power supply, and the Vernier LabQuest interfere as little as possible. Then we're going to find the direction of north. So north faces this way according to the compass. And then we're going to align the tangent galvanometer with this north. And then we're going to place the compass into the tangent galvanometer while keeping the same alignment. If you find that you've misaligned it a little, fix it so that the direction of north faces directly with these coils. Then what we're going to do is increase the voltage and then use the current limiter to fine-tune how much current is passing through the tangent galvanometer. Our goal is to have the compass turn 15 degrees, 30 degrees, 45 degrees, 60 degrees, and 75 degrees away from North Pole. Using these, we can calculate Earth's magnetic field.